and we should turn to the first strategies that we will be covering in this chapter, which is a bond plus an option. Now, the first strategy, broadly called principal protected note. Now, what is attractive about this strategy? It allows investors to take a risky position without risking the principal that they are investing. For example, let's say I have saved $1,000, and I was offered to invest in a 3-year zero coupon bond with a principal of 1,000. So the face value of this zero coupon is 1,000. And I was also offered to invest in a call option. The underlying for this call option is a portfolio of stocks, and their value today, the value of the portfolio is 1,000. And I'm offered to invest in this call option, which is at the money, which means the strike price is also 1,000. But the option could be exercised only after 3 years. Now, all I can invest in is 1,000. So I cannot invest in more than 1,000. If I entered into these instruments, then I created what's called a principal protected note. In what sense? We will see now. Now, first, we want to see how exactly I can enter into a principal protected note. Now, assuming that the zero coupon bond is priced today at a zero rate that equals to 6%, that's continuously compounded, which means the price of this option, which will pay or which has a face value of 1,000 that will be paid after 3 years as well. It's basically the present value of the 1,000. So we discount the 1,000 using the 6%, discounting it for 3 years. We will get that the price of the zero coupon bond is 834.27. Now, the call option on the stock portfolio that has a value of 1,000 and a strike price is 1,000, and an important feature of this stock portfolio is that it provides a dividend yield of 1.5 per annum. Now, assuming that we looked at an option pricing model that represents the reality, or it is what investors use to base the prices of options, we found that the call option is cost now 164.73. So so to put these two prices in a visual representation, now this 1,000 we can break it into the zero coupon bond, 3 0 coupon bond, the price of 835.27, and a call option. The price of the call option 164.73. So the total amount I will pay is 1,000. Okay. Now, What will happen if the value of the portfolio after 3 years was more than 1,000? So let's take, for example, the value of the portfolio was 1,500. So ST 1,500. So the zero coupon bond will have a value of 1,000. And the call option will be in the money or out of the money. Well, strike price 1,000, ST 1,500. So is it in the money or out of the money? Since we're dealing with the call and the call has the right to buy, then it is in the money. It makes sense to buy at 1,000 instead of buying at 1,500. And the payoff will be basically the maximum ST minus K or 0. In this case, ST is 1,500, K is 1,000. I am going to receive 500 from the call option, 1,000 from the bond. So in total, I received 1,500. Okay. Now let's look at another scenario. Let's assume that ST, instead of being 1,500, now ST is equal to 800. The zero coupon bond will yield the same face value, which is 1,000. The call option will be out of the money, which means that the payoff will be equal. So in total, how much I'm going to receive? I'm going to receive 1,000. What do you notice here? Well, what we observe is that if the portfolio's value increased beyond the strike price, then I will gain from the upside potential. Right? But if the price of the portfolio went down, then the zero coupon bond will provide me with the protection to be to enable me to receive back my initial investment. Now, we cannot say I did not lose, because remember, the time value of 1,000 is today is not the same as 1,000 after 3 years. However, the principal protected note helped me to protect my principal, so I will be able to retrieve it back. Okay? So that's the whole idea behind the principal protected note. Now, what we will examine next is when such a strategy is viable, when we can create such a strategy. Well, an important feature in the option that we used in the example is that it provides sentence. Why that's important? Well, we will see in a second. Now, this is a program, an Excel program that comes with the book. It's called Derivagem. It illustrates or it gives you the chance to use different option pricing models that we covered in the class to examine the effect of different factors on the option price. Now, we found that for the stock portfolio that pays 1.5 dividend yield every year, which means in year one we will receive $15. So 1.5 out of 1,000, it will be 15. And since we will be, we are dealing with this portfolio for 3 years, we will to find what's the dividend each year. The volatility is estimated to be around 14.37, and the time to expiration is 3 years. The price is similar to the stock price, which is equal to 1,000. If we calculate, it will give us the price of the call option equals to 164.73. Now, remember, what did we learn in chapter 11 about the relationship between the call option price and dividends? Is there a positive relationship or there is a negative relationship? Well, since the dividends will decrease the stock price after the ex-dividend date, then the intrinsic value will decrease, right? Because the intrinsic value is the maximum between ST minus K or 0. So if ST went down, the intrinsic value will go down and the price of the call option will decrease. Now, which means if there was a dividend, if we calculated the price of the option including dividends, and then we remove these dividends, what will happen to the call option price? Well, let's see here. We remove the dividends. What happened to the price of the option? Now it's 195.81. Now, if I chose a stock portfolio that does not pay dividends, will I be able to create the principal protected note? Well, the zero coupon note will be the same. The price of the call option, according to the Black-Scholes formula that we will learn in chapter 15, the price is equal to 195.81. Now, is the total equals to 1,000? Well, the answer obviously is not. 195 plus 835.27 . So the sum of the two components of the principal protected note is 1,031.08. Now, for my case, I only can afford to invest 1,000, which means, can I create the principal protected note if the price of the call option is 195.81? The answer obviously is no. So one important factor that makes this strategy viable is choosing a call option on an underlying asset that pays dividends. Why? Because I want to make sure that I can combine the call option with the zero coupon bond to be able to create the principal protected note within the capital that I want to invest. Okay. Another variable that makes the strategy feasible or not is the level of interest rates. In our analysis, initially, we assumed that the level of the interest rate is 6%. Now, assume instead the level of interest rate is 3%. What does this mean? How this will affect the construction of the principal protected note? Well, it will affect the price that we will pay for the zero coupon bond, right? The call option will not change, but the price of the zero coupon bond will change. Let's see. So we calculate what should be the price of the zero coupon bond, assuming that the zero rate is 3% instead of 6%. We will find that the price of the bond is equal to 913.93. Now, adding the cost of the zero coupon bond and the cost of the call will result in a total cost of 1078.66. Again, can I create now the principal protected note if these are the price of its components? If all what I can invest is 1000, the answer is also no. So another factor that makes this strategy viable is the level of the interest rates. Why? Because the level of interest rates will have an effect on the zero coupon bond part. The higher the interest rate, the lower will be the price, which makes the strategy viable. Finally, an important factor also that will affect whether or not this strategy would be viable or not is the volatility of the portfolio. Now we assume that the volatility is closer to 15%, 14 point something. Let's see if instead the value of the portfolio, the value or the level of the volatility is 25. And assuming that there will be dividend payments in the next 3 years, so because this portfolio yields 1.5 dividend, we calculate the price of the call option. It becomes what? 223. Now added to the cost of the zero coupon bond based on the 6% yield, it was 835 plus this. Definitely we exceeded the 1000, which makes this strategy not possible. Now some of these factors are under our control and some of them are not under our control. For example, choosing an underlying asset that pays dividends, we kind of have a choice with respect to that, but the level of interest we cannot change it. The volatility, it also depends on the underlying you choose. If you choose an asset with a high volatility, which means the cost of the call option will be high, so the principal protected note will not be feasible. Now, if choosing all the parameters related to the underlying of the call option, and we still could not create the principal protected note, what could we do to make the strategy feasible? Now remember, initially here, what did we choose? We chose a strike price that equals to 1000, right? So the option was at the money. Now we could sacrifice part of the profit by increasing the strike price. So instead a strike price of 1000, we can choose a strike price that is equal to 1100. So the option is currently out of the money. If that's the case, how this will affect the call option price? Well, remember, we learned that there is a negative relationship between strike prices and call option prices. If we calculate, we find that the price is 182, assuming that we want the volatility to be at 20%. Now, cost of the call option plus the cost of the zero coupon bond do not exceed the 1000 that I want to invest initially. So we can add some features to the call option that will, or change or modify some features in the call option to make the price of the option decrease. We can add features to the call option to lower its cost. Now, instead of buying an ordinary call option, we can buy an option called a knockout call option, which belongs to a class called barrier options. Now, the idea behind this option is that let's assume the strike price for this option is, let's say, 100. Okay, and there is a condition that if any time from the time we entered into the option until the expiration date, the price reached the knockout barrier, let's say 150, the option will expire worthless. So for example, let's make a movement in the price of the stock. The price of the stock was like this, up and down until the expiration date. It did not exceed the barrier of 150. The option was in the money and the holder of the option exercised it. Now, if the price of the option was fluctuating at any time, it exceeded the 150, and this option will be worthless. It will expire worthless. So even if it went down later on, it doesn't matter. Since it exceeded the knockout barrier, it means the option will expire worthless. So now, an ordinary call option, okay, that does not have this limitation, and a knockout option, which one you think has a higher cost or higher premium? Well, the ordinary call option does not have this limitation, so it should cost you more than the knockout option, because the knockout option has the risk of being expired worthless even before the expiration date. So adding this feature will make the cost of the zero coupon bond plus the cost of the call option could be within the capital you want to invest in the principal protected note.